Welcome back to another episode of KJ's Playhouse. At this time, we will be showing you a quick video on how to do trigonometry. Let's begin. To start off simple, we will do sine. Is this marker dried out? Dried out. Okay, it's okay. To do sine, we will have to make a right. Hang on. A right we have to make a right triangle. Well, then, on the slope is hypotenuse. On the left side is opposite. And on the bottom is adjacent. To calculate sine, we'll have to put an angle right here. Then we'll use any letter. You will go with angle F. Then right here, a 90-degree angle. And then to calculate the sine of angle F, we will have to divide opposite by hypotenuse. Let's pretend adjacent was 7, opposite was 5, and hypotenuse was 13. To get this right, first the number across this, which is opposite, divided by the number across the 90-degree angle, hypotenuse. So if opposite is 5 and hypotenuse is 13, the sine of angle F equals, in simplest form, 5 over 13. This next one is a bit harder. And this next one will be cosine. We do the same. Except the angle will be angle A. Adjacent will be 4. Opposite will be 10, and hypotenuse is going to be 19. So, cosine is a bit different. Unlike normal sine, which is opposite over hypotenuse, for cosine, we will be doing adjacent over hypotenuse. So, if adjacent is 4 and hypotenuse is 19, we will have to do this. We would have to make this in simplest form. But because 19 as the denominator is a prime number, the cosine of angle A equals 4 over 19. The third trigonometric symbol we will be explaining is known as tangent. Tangent is just like both of these, but it's much different. Let's take our right triangle. Our angle will be angle K. Adjacent will be 17. Opposite will be 8. And hypotenuse will be 20. Unlike a normal sine, which is opposite over a hypotenuse, we will do opposite over adjacent. So in order to do this, the number across is opposite, and the number across the slope is adjacent. Because opposite is 8, the adjacent is 17, the answer is 8 over 17. Next, we'll have to simplify this. But we notice it's already simplified since 17's a prime number. This means that the tangent of angle K equals 8 over 17. The next one, we will be doing sine, but not just any sine. We're going to do inverse sine. Let's take our right triangle. The angle will be angle D. Adjacent. No, that's the wrong side. Give me 1 second to erase it. One second. Gotta erase it. Okay, there we go. This is adjacent. And it's gonna be 5. Opposite will be 4. And hypotenuse will be 1. This is normal sine, right? Well, no. Normal sine is opposite over hypotenuse. Because it's this inverse sine, the sine of this angle is reversed. So instead we will do hypotenuse over opposite. And it's actually easy because 1 is the unit number. It's the only number to have 1 factor. Meaning the inverse sine of angle D equals 1/4. Up next, we have the inverse of the other sine. And of course, we are talking about inverse cosine. Ow. Sorry, there's just dirt in my foot. Just dirt in my foot. Let's make our right triangle hypotenuse is going to be 7. Opposite is going to be 11. And adjacent will be 19. Unlike normal cosine, this is the inverse. So instead of adjacent over hypotenuse, it's hypotenuse over adjacent. Oops, forgot the angles. Oh, if hypotenuse is 7 and adjacent's 19, the inverse cosine of angle G equals 7 over 19. our last inverse of the first three is inverse tangent. So, unlike normal tangent, instead of doing opposite over adjacent, because it's inverse, we'll do adjacent over opposite. This one we will have to simplify. Inverse tangent equals 12 over 10. As you can see, this is not proper. So instead, we're going to have to convert it into 1 and 2/10, which is still improper. So, dividing these 2 by 2, inverse tangent in simplest form equals 1 and 1/5. Okay. Moving on, we will be doing secant. So, secant is one of the 3 trigonometric symbols that cannot have an inverse. And we're going to talk about it. So, because, let's pretend this angle's got to be angle E. We will have to do something a little different. Instead of dividing 2 sides. Instead, we will do 1 divided by the cosine of the angle. Instead, dividing 2 sides is involved because cosine is adjacent over hypotenuse. The cosine of angle E in simplest form is 1/3, meaning the secant of angle E equals 1 divided by 1/3. The second to last trigonometry symbol is going to be cosecant. So the cosecant of this angle B is going to equal a little something that involved with the sine of an angle being involved. In order to find the cosecant of angle B, we're going to have to do 1 divided by the sine of the angle. And because sine equals opposite over hypotenuse, if opposite is 14 and hypotenuse is 7, the sine of angle B would be 14 over 7. And in simplest form is 2. So the answer is the cosecant of angle B is 1/2. Our last trigonometric symbol is also the hardest one yet. Cotangent. Hang on, I got this misplaced. There we go. Sorry if it's messy to you. So the cotangent, it is just like the tangent of the angle, except the tangent of the angle divides 1 by it. So the cotangent of angle C equals 1 divided by the tangent of the angle. Because the tangent is opposite over adjacent, if opposite's 2 and adjacent is 7. Give me 1 second. Okay, let me fix that to adjacent. The tangent of angle C equals 2 over 7, which leaves the cotangent of the angle 1 divided by 2/7. And that is your full guide to trigonometry. Make sure to subscribe for more.